Hello guys, today I will teach you how to make this wheat field in geometry node, also having a way to control the strength and rotation of the wind, and an interactive object that allows to move and kind of touch the individual areas. If there is enough time, I might also teach you how to properly texture the wheat. So this is what we first see when we load a Blender. Also, don't forget to save your project in advance and save regularly. So what we can do now is we do select A and delete everything there is. And the first thing we do is we add a plane. This plane will be the base of our geometry node. Next thing, we go to the geometry nodes tab and we create a new. I will call this uh, wheat because that's is what we will be making, and I'll be moving this around way back. If you want it to snap to the canvas like I have, select this one, so make sure it's on. This is how it looks like when it's off, and this is how it looks when it's on. I like to do this to have some proper control of where to put things. Also, what you should do is go to Edit, Preferences, Add-ons, and tap in Node Wrangler and make sure this is connected. That's one of the basic things you should do. Also, press Save Preferences before you quit. The first thing we want to do is create the points for our wheat to stand on. So what we will do is create points on faces, and we will put it in. You see how there is random points on the faces, and you can change it using the random seed, of course. And then we want to do something, and we want to do this for each point of the point we have, so we can later have control over the different points, and we can change every individual point with some individual things. When you put it in, when you put this one into the group input, make sure to plug the lower one in and not the upper one, because this one just gives the geometry you plugged in originally. Now we wanna instance something on these points, so we wanna do this, and now everything disappears, and that is normal because we have instanced absolutely nothing on this point, but we wanna do so still. So we will add a curved line, which is the base we will use for our nodes. So if you look at this, we have our first read stems, and I looked up how big they are, and they are usually around 0.6 meters. What I will also do, I will show you how this works. And now we only see one, and I'll show you the indexes. We currently have 2 points, which you can see by selecting attribute text. You see we have point 0, which is the bottom point, and point 1, which is the upper point. But we want more points to control the way it looks. So we will do a subdivide curve. Now we have 3 points, 0, 1, and 2. And these points will be very necessary later on, so we will be looking a lot at this viewer in the future. But for now, let's just mute this. So the next thing we want to do is we want to change the position of this point with index number 2. And the way we do that is by using a set position node, which allows us to change the position of everything, but we don't want it. So what we will do is we will go to this index node I got here. If you didn't add one, you can also just press Shift A and go to index, and you will put it in a compare equal node, so that any point with this index will move, and we want to put it to 2 because we want to move the upper point. We can temporarily hide this one because we don't really need it anymore. I also put this in a frame to better understand what everything is. Now, we don't want to decide manually the position for each point because it will be a lot of work. So what we can use is a noise texture which allows to randomly position each point. And we will also already put it in 4D so we can animate it later. And if I change this, you can see how it randomly positions the point every time. Let's put it back to 1. Now, the values I found best, I will just plug in, and it's basically just changing the scale to 2. That's what I found was the best thing. But right now it still isn't animated, as you can see. So we will have to do that. And first of all, let's make sure it is animated in a sort of way. And we will do that by using the scene time node and putting the frames into the W, which actually already animates it a little bit. But of course, this is not what we are looking for. As you can see here, there are still multiple mistakes. So let's go back and actually change the way it works. And the first thing we will do actually is add an empty arrow, and we want to choose a single arrow. I will move it up by 1 meter and rotate it over the y-axis by 90 degrees. So now you can see exactly what I'm seeing. Also, I put the size on 0.25 meters and the scale on 10, so for later on it's corrector. If you want to be able to click off this without moving away this page, you can press this pin so it's selected and you will always stay on this geometry node tab. So now we have this. I will rename this to strength and rotation because it will control the strength of the wind and the rotation in the future. And we can select this and drag this in here. And what we are going to do is we're going to multiply the frame with the scale. So it still doesn't change a lot, as you can see, but we will edit this at this later. And what we also want to do is copy this and instead of multiply, put it on divide. And we actually want to scale this with vector math scale and plug this one in here. You want to divide by 100 and I'll show you why in a moment, because we're going to plug in a value of 1 which we will be later able to optimize using this tab right here, which I will do in the very last moment. And we divide it by 100 to make sure you can see properly the movements. If we didn't do that, look how fast it would be. It would be not what we're looking for. And by changing this value, you can change how fast the wind is going in the future. So let's actually give this frame and set this to speed wind. So now we have two ways to control speed using this one and this one here. Of course, the points are still moving exactly the same and we don't want it. We want there to be a little difference in there. So let's actually select this and make this the speed, because that's what it is. And now we will change the way it goes separately. And we want to do that using a random value, set not so to float, but to vector. And when you put this in here, you can see it changes nothing. And that's because every point gets the exact same random value. And you can change that by using the index here. And that's why we use for each element, so every point can get an individual seed for everything. So now you can see they are moving separately. Now, I also used some other things as a random value again, and this time a float, which I put in from minus 0.1 to 0.1. And I don't remember exactly why I did it, but it gives off better results doing this. And when you plug this into here, I thought these were the best results, but we still want to be able to change this a bit. So you can also decide what the difference is in the flow. So now you can see they are still going pretty together in their flow, and we want to be able to change that. So we will actually do a math add node here, and we want to do something like this again. So we do a value and we will plug this in here. And you can see right now, if I put this to 0, they will all go together. And if I do them to plug them in 1, they will all go differently. So let's make this the node and we will call this the difference in flow. This is not really what we want still at the end. We want to still change a lot of things. And the first thing we want to do is we want to actually decide how much it can move, because now it's always giving a value from 0 to 1, because noise texture gives off white and values towards black values, which means 1 to 0. And we want to actually be able to change that, and we can do that using a map range. and we will plug this in. And you can see here it's from 0 to 1, which is exactly what we need. And the values I thought were best were these ones. You can just copy what I do here. And this still is not what we need, because we want to be able to change the X and the Y axis, but not really the Z axis. That's not really necessary, so we use a combine XYZ node. So now you can see it only changes on the X axis. And we also wanted to change a little bit on the Y axis. So let's Control Shift D. So it says plugged in, and plug this one into the Y axis. We want to also change these values, put them a little lower. So I put them to these values, which made it so there is a slight difference in how they change left, right, and front and back. This, of course, is still not what we want, because we want to be able to control it using this. Because if there is a stronger wind, the reed will be flatter and the top will go away further. So let's do this. And how we will do this is using an add node, add node. And we will do the same for both, of course. But we will start with the top one. And we once again put in the object info from this arrow. We want to put the scale in a multiply. And the reason we want to do this, and not a vector multiply actually, but a normal math multiply. Because we want to do this because if we add this, it will be way too much. And I decided to multiply it by 0.01, which is actually the same as dividing it. So now you can see it goes further if you make the wind stronger. Of course, it's not mathematically correct because the reed would not be getting longer, but that's a detail you don't really notice in the end, and I feel like it's not really necessary to add that. Actually, we'll need this value to change something else, because we want to get the possible minimum and maximum value of this. So we will set this to min max value, because we want to actually be able to map range this. So we want to once again be able to control how far this goes later on in the add. And it's not actually this value, but a multiplier value you want to plug in here. And we want to be able to add this to the map range for the y-axis we made earlier. And the values I use, we want to be plug the minimum into the minimum, the maximum into the maximum, and I decided to use these values here, 0.001, and this actually has to be negative. And this is what I thought looked best for whatever we are doing here. Can call this limit, because we limit the way it moves. Limit movement. The next thing we want to do is change the second position of the point. While it's not really necessary to do that, it looks way better if you do that. So I will show you how to do it. You copy this one, set position, and also this one, because we want to change another point. And I will actually use a viewer again. You can see we have 0, 1, and 2. But I don't want to change either of these. I want to change a value here in between, so I can put this a little backwards, so it has more of a flowing motion and less of a almost immediate motion. So the way I will do that, I will add more points, and we will do it by subdividing the curve again. So now you can see I have another point here, and the points actually changed. You can see here now it's 2 and now it's 4. This will not impact what we did before, but we can now use more points to our advantage. And if you remember, well, this was set to 2, we want to set this to 3 now. So you can see if we change this, it will only affect the third one. The great thing about changing this point exactly is that we already did most of the math before. We only need to actually scale down the amount of force we already had. And we will use this one actually with Control Shift D and Alt P to get it out of the frame if you made one. And we can already plug it in. But now you can see it's even further because the point is in the center of this line, which was already moved. So if you move this now, it moves again with the same amount this point moved the first time. And that's exactly what we want to change. And we can change that by using a scale and plug this in here. Now the scale is set to 1. The value I found best is minus 0.15. So we will actually move it back by 15% of what the value of moving this point frontward was originally. So now you can see it has more of a flowing motion. Definitely if you put this a little stronger, you can obviously see it. So we will call this point 2, and we can actually call this entire part point 1 or point top, whatever you prefer. The next part I want to add is actually a huge leap forward from what we did earlier. And that's because this will make it easier to visualize everything later on. And I will actually already be deleting these ones. We will be using again, most likely, but not right now. And what we will do actually is already make the shape of the weed. And we need to give it shape, so we want to make it a mesh actually. Curve to mesh is the node we use for that. And what I thought was best was to use a curved circle because it's of course the most versatile. And before I plug it in, I want to say put it on 6, definitely if you have a lower end laptop. So now you can see there is very little detail, and we want to put it on 0.001, and already you can see there is almost no difference to be seen between 6 and 32 vertices. So put it lower to keep your performance higher. But of course, like most plants, it gets smaller on top. So to change that, we will use a spline parameter, and we will put the vector into scale. But now it's the wrong way around, and we can change that using a float curve by putting this one up and this one slightly down. You can see how it changes. And these are the values I thought worked best: 0.75 and 0.9. You don't have to copy the exact values I use, but these ones I thought looked really good. You can also add a level of subdivision using subdivision surface, which makes it smoother, but I suggest keeping it a really low value. Definitely if you're going to be using more of the weed, because it will just completely destroy your performance. But I will plug it in so we can change it later also. So we call this subdi weed, shape weed. The next thing I will do is actually already change this to a quadrilateral, and it's so you can view better what I will be doing next, because otherwise it might be slightly harder to see. I will put this on point 1 and actually will fill the gaps so there are no open tops or bottoms. This is only to see better. We will delete it later on again. And what I will do actually is allow it to lower random patches of points, so it looks like there is a sort of wind flowing through the entire field. And we want to do that again using a set position. Again, and the workflow will be very similar to what we did before, but also not entirely the same, of course, because we will be using a noise texture once again. And we will put it into select, and we will move these points down by 0.2, which I found were the best values for the height of the weed. This is of course not what we want, because now it selects everything, because everything greater than a value of 0 is selected, and the chance to get a value of 0 is not really high. You can see there are lots of values, but not any zeros actually. Let's delete these because these points are kind of in the way. So we can already change it by using a color ramp, and now we can clamp this way up to like 0.6, and we will move it a bit back to 0.8, so there are some extremes, and you can see some of these are lowered and some are not. And when we change this to 40, we can already animate it. But of course, we don't want to lower the entire plant because it would be unrealistic. We only want to lower the top version. So the way to do this is by adding an and, which is boolean math. And by doing this, we basically say this has to be true and whatever goes in here also has to be true to before you can make this. And now there is nothing in there, so you can change it. You can make an equal note in here, and it's great it's set to integer math because we want to add an index. So if the index is 0, it will also move down. But it's still not working, and there is a reason for that. That reason is very simple. We need to realize our instances. And this makes it so that every different line, so curve, is once again its own thing. Because here it makes it all one mesh. And here it says, okay, but the meshes are now separate again, so you can see the difference when I mute this here. That's how you do it. And we don't want to change the lowest, but actually the highest point, which was 4, if you remember. And then later we will also be lowering 3. And we also want to change amount we lower. So I used a map range once again. And this time I did set it to vector because there are some side changes I want to do. I want to be able to move from 0 to 1, of course, because once again it is from a node sector and a color ramp, with white being 1 and black being 0. And I want to change these two values to minus 0.25 and these to 0.25. And this one I actually want to change to 0. And once again, I don't really remember why these values were the best, but they did work. And I want to compare this, and if this value would be greater than some value, and it doesn't have to be a vector, it can be a float, then we want to make it true. And now, if the value is greater than 0, but we don't want it, I will use a value node to visualize it better. And the value I thought worked best was negative 0.15. So now you can see some are being lowered. And you can actually visualize this better using a higher density. So now you can see these are together and they are lowered. So this is actually exactly what we want. And once again, I will change the scale and I change it to 2. So now you can see the patches that are together are lowered together also. When you see the wind blowing through a field, you can see the patches low together instead of separately. And now we will basically do what we did before. But first of all, scale, I will put a value node in. Put it to 2, of course. Edit patch size. We wanna once again animate this so it moves around. And once again we can use a scene time node using frame, but of course it's going too fast, and we also want to be able to change it using the speed of the wind. So we will use a scale, which will be a vector math scale, of course, and we want to scale it using, of course, the arrow scale. So now you see it changes a little bit, but we also want to be able to move it with this scale. So I will put it like this. It will be slightly faster. So like this. But this is too big of a value, so we want to divide it actually. Divide math node. And we want to divide it by quite a big value actually, because I believe it's 1000. So now you can see once again the patches are together, and the speed also changes dependent on the wind. So now you can see the patches moving individually, and now they are faster, which is exactly what we want right now. This is lower top, and I will move this a bit further there. And I also want to be able to lower the second point, which will be very easy to do actually, because we will do Shift T We put it here. We want to copy this one also and plug it in here. We want to also use this value here, but we want to change it to this here. And we don't want to lower the same amount, but with slightly less. So now you can see the way it's lowered, it's not as much. I will put down the amount of points again, so it's better to see. And don't forget to regularly save it, definitely if you have a lower end PC. And this will be able to set lower points too. The next thing I want to do is add a way to interact with it. So imagine if you would put your hand on a field, you know it would move it, because of course you move things with your hand. And once again, we want to do is using a set position, and we actually want to create a position. So I use a UV sphere and actually scale it down quite a bit and apply scale. If you scale this up, you can see how it changes. If you want to properly scale it up or down, you should press Ctrl A, then use scale, so you properly scale it the way it should be scaled. I will put it back. So as long as this is all set to 1, it will be scaled properly. If you scale it up, it will be scaled up appropriately, and when you press Ctrl A and scale, it will change back to 1. And this UV sphere we'll call interaction and plug it in here, because of course we will need it. We want to calculate the distance between the sphere and the point we want to move. So we want to use the location and actually use a distance node, vector meant distance. And I plug this into the second one purely because it looks slightly better. And now this is something interesting we have to do, because we need this point and we want to sample at index of the geometry. We want to sample a vector because a position is a vector, and of the point. And we want to sample the fourth point because it's the highest point, of course. And what we want to value is the position of this point. So right now we have the position of every point, and it still changes everything, of course, because we have to select only index, compare, equal, and it has to be 4 once again, as we did before. So now you can see how it changes based on the distance of the points. So right now it's very close to these points, the original position of these points, a bit farther away from this, and that's of course not what we want. We want to do it the other way around. And the way we want to do that is we want to compare the position before we want to move it. So now we want to make the selector of what points to move. And I will see if this less than, and not actually less than, or a bit less than or equal. And the value I use currently is 0.5, which is not exactly the scale of the according to the scale of this one. I don't know exactly what I should use, but it doesn't really matter. The only problem with this is it calculates from the center, so the orange dot, and not whatever is around it. So only a sphere will actually be able to do it correctly. Every other shape will move it without really touching it. So now if this is true, it changes. So you can see how it changes if it's close to it. And that's exactly what we want, of course, but only, of course, some. And we want to again use a Boolean math, plug it into and enter this here. So now you can see how the top position changes only. We don't actually want to use only those, but we also want to be able to change 0.3 so it looks better. Ctrl Shift D and lower it to 3. Plug it into an OR, so now it doesn't say this position and this position, because it would be impossible. No point can have index 3 and 4. But now, if it has this index or this index, and the value is less than 0.5, you can change. And so you can see how it edits. And I will actually lower the value already to like 0.3, oh, 0.3, which is probably more realistic to the actual position. We don't only want to change the position, but we also want to know how much it has to change and in what direction it has to change. Of course, we will only be lowering it downwards, not upwards, because or sideways, because it would be a lot more math for little output. We want to separate the distance actually, and we only want to use the z-axis, which we will use in a map range, so we can map how much it has to change. But we don't know what is the minimum and the maximum value of the distance. The minimum we know it will be 0, but it's still useful to use min and max value and plug the min into min and the max which we don't know into max. And now something interesting, I will put the minimum into this so it changes to the maximum value of the movement is now the minimum value it is, and the minimum value is minus 0.15, which I thought was the best value, and I plug this into a combine XYZ to the Z axis and I change it to offset. So now you can see it lowers in certain moves, right? Oh, so not all at once, but in a certain amount. So basically what this here says is you move it downwards. If this is true, you move it downwards by minus 0.15, and the maximum you can use is actually 0, so it moves downwards with minus 0.15 and it moves upwards with using 0 actually, which is why we do this interaction. So now that we have added interaction, we can go to the final stage, and I will actually already delete the quadrilateral and add the curve circle back. And the final stage is actually at the ear on top, because right now it's only a line actually, and that's of course not what read really looks like. So I will use this point and every one of these points, of course, actually, and I want to use the very top point once again, so you can see that by plugging index also into the viewer, and I want to add on this point the ear of it, and I will not only use this point but also the rotation, and I will rotate using the strength of the wind and the way it also rotates. And right now I think of it, I actually forgot to make a way to rotate the reed actually, and we can do that right now. So once we go back to the instance on points node here, it is actually very simple to do that. So we will take the strength, so the arrow, use the rotation, and I will move this backwards a little bit to create some space. Oh, we don't want to do that. And we want to use the rotation to rotate it, and you can see it's not exactly as we want it. So we will add a rotation node, which and use 270 degrees to rotate it. And as you can see, it still does not work as it should, because it lowers it. But when we plug it into the local, it starts working the way it should. And right now we can, so this is the rotation right here, and we also actually want to randomize a little bit of the scale, because now they all look very similar, and you can really simply do this by using random value set to float, and the values I thought were best were 0.65 and max 1 into scale. Now you can see they are already different, but I still like using the index to change the seed. And now they are all very different, and you can see how our animation works. And here they are lowered from the ball, so you can see how our interaction works. So now we can go back to the place where we start making the I actually didn't know how to pronounce it. And we want to once again instance something on a point. We want to, of course, join the geometry because we want both the geometries. And I will put this in here and this in here. So now we have this geometry which we can't see yet, which we can quickly visualize using a cube. 0.01. So now you can see on every point there is a cube. We don't want that only the last. And if you remember well, we use index equal, not this, compare equal to 1, 2, 3, 4. And in here, so now we only have a cube on the top. But we don't want to use cubes. We want to actually make our shape, and you could make a great shape, but I want to make it in geometry nodes myself. The way we will be making it is not using a cube, but actually a cylinder, which is way more versatile because we can have the top, side, and bottom. You plug this in, you see it's way too big again. So we will make the depth 0.05, which is the real height of the ear or and 0.005 the width. And we can actually shape it by changing the side segments to 2. And we don't want it to be the center on the point, but we want it to be the top. So we want to transform the geometry with half of the depth, so it will be 0.03 because I misread it. This had to be 0.06, not 0.05. So now it should be on top of there if you added 0.03 and not 4 as I did. Now it's exactly on top. So we want to actually scale elements. And if you now select the top vertice and scale it by 0.5, which is the value I used, you can see how it changed. And that's because in our value we used this one. Actually, you don't have to put it 32, 6 is great enough. Because if we would use 1, there would be no side segment, and by using 2, there will be a loop cut to change geometry. I want to do it for both the bottom and the top. So now we have this, and this already is the shape you want to use. And now we want to be able to rotate it properly, so we will once again be dragging this in here and using the rotation to rotate the rotation. And if you remember well, we put it on local rotation and 270 degrees, but I don't want to do this again because right now it would mean it would always look up, and we don't want it. We want to also rotate it around the sides so that it's also more rotated. More rotated if the wind is stronger. And we want to do this using the scale, and I'll use a map range, not set to vector but to float again. Actually, I plug this into value, and I don't know what the max value will be, but 25 is a great number I found. And for this one, we want to set the max value, I believe, to pi divided by 2. I will not go really into the math of this because I'm also not qualified enough, and it would just, we want to combine it in, not in the x-axis but in the y-axis. And if you plug this in here, you can see it's rotated wrong, so we want to actually add using vector math. And here we wanted to use 3 times pi over 2. And now you can see it's rotated properly and it rotates further if we make this wind stronger. And it also rotates around with the ear. This is to add the ear. And we could already make our material, but I want to first add something, and we have to realign our instances on here. So I will go to shading tab, select this, and the first thing I will do is go to cycles, which I prefer over EV, which is of course just a personal preference. And right now we can already see there is no floor. We can change that, and we go here at group input, copy the join geometry node, and right now we have our floor back. So we want to go to the shading tab, and the first thing we will do is create, of course, a new, and then we will start with the ear shape. So I start with the ear because basically the width will be almost the exact same. And I will start by using a noise texture actually to add noise. And now we can see something, but if we were to plug it in here, we can see nothing because there is no light, which we can add by adding a sun. We rotate it and I will put it to 2 actually to get a slightly stronger light. I will copy it and rotate it 180 degrees. And now we can see properly our entire field. But now I will plug this in here, and I want to use these values. 100, set this to 2 and keep actually the rest of these. And this is why we need a node wrangler. We press now Ctrl plus T, so it does this automatically. It's just a way to do it faster. You can actually do it without it, but it would be using so much time. And now you can see there is quite a lot of detail, which is what we want, of course. And we want to do a color ramp to push the colors a bit closer actually, like this 0.45 or something, and this like 0.8. And these colors are still too far away, so we will bring up the value of this one to like 0.45 and lower the value of this one slightly less to 0.7, 0.8 maybe. This looks kind of great, and I actually want to mix these colors, so I want to delete this and put this in mix color, and we want to make sure it's set to color and mix. If it's set to something else than mix, it will give another result. I want to copy this and plug this in here, and I'll change the value. Actually, I'll change the value of this to 0.25 first of all, and of this one I will keep set to 1. I will set this to 500, the detail to 6, and the detail doesn't change yet because we have to change the roughness first, and we'll put it to 0.9. We'll also make it slightly darker, so we'll set it to a value to like 0.2. So now you have detailed and less detailed parts for the ear, and we can't actually see anything except on the floor, and that's because in our geometry nodes you need to of course set material node and put it to ear. Don't forget to save again because it might crash, you never know. And now you can see what we made actually. So this is our first one, this is the second one, and this is how it mixed. And what we want to do now is add a color ramp once again, a color ramp, and keep this one set to white and black. With our white value we want to put way back to like 0.3, and now we can start adding our shape using a mix color node again. And we want to set this into the vector, and the values I am going to use are these. Pause it if you want to copy the exact values, and this one. Once again, pause it if you want to use the exact values I use. This is how it will look like right now, and later it would look something more like this, which is already quite close to the result we want. But of course we are not there yet, because this is might be our main color, but we also want a difference in color. So we want to actually select random patches, and we can use it by using the random per island. Now you can see, you should be able to see some of them are randomly gray, and this is actually not what we wanted. So I found a fix. What you want to do is go to realize instances, press Ctrl X to delete this, go to shading, and instead of using random per island, you're going to go to object info random and plug this in here, and you can see now random ears are selected. This will allow you to change the color from every ear from now on. And we want to actually already not mute it, but make a map range. And why we want to do that, I'll show you first. U saturation value is a very important node, because if you plug this in here, you can see we get the color we had before, and you can actually change a lot of information using this. And if you plug this in here, we get values ranging from 0 to 1, which if you remember 0 being black, 1 being white, and we don't want it to be 0, 1, we want it to be strongly around what we had before. So what we do is make this point 35 and this like point 55, and now it's very similar. But you can see if I up the amount of points there is, like I'll break it into 100. You don't have to do it if your computer is not strong enough to handle it, and even if it is save it regularly, it will save you a lot of pain later. So now you can see they are randomly colored, but still this is not the end result we want. We want also to make big patches the same color to show a slight difference in the ground, where you can see there might be less or more water, or there might be slightly different sort of ground, which will make it even more realistic. So what we do is we add a noise texture. Once again, plug this in. I put this value to 3 and kept the rest. I used a color ramp actually to bump the textures closer to each other, using 0.4 and like 0.5 maybe, maybe this was even 0.35. And using this we can actually, in the same way we did before, we will do Ctrl T, and what we will do now is we will keep this in generated, but make this one 0, so everything going upward will be the same color as below. If we crank this in a U saturation value, of course again we get the same problem as before. I'll show you, it makes random colors. We do not want it, and once again if you put it into object, it is great. So we want to once again map range this, and I don't know if you're able to hear, but my computer is also starting to struggle slightly, and with this value to 0.45 and this value to 0.5 actually, and that will make it give beautiful random coloring. I'll plug this one into this one in here, and I will use the following settings. I put the roughness in 0.75, IOR into 0.1425, and I will leave it to that. You can also add a little bit of texture using a bump node, which I use this color for, and the color ramp vector, which I put on these values, 0.4, zero point 0.2 and 0.5, excuse me. I use it into the bump height, and I put the strength in 0.3, and I put the normal into normal, of course. And what it does is it creates a little bit of fake depth, which adds great shadow. And I can exaggerate it using 1 here. You can clearly see there is fake depth, but a subtle amount like 0.3 is great for here. And what we want to do now is I'll first of all save this, so if it crashes we can get it back easily. I'll lower the amount of points again so my laptop will not explode, and I will copy this pressing the 2 here, and I'll change this to wheat, for example. I will copy the set material and change this to wheat once again, and now we can start making the stem, of course. It will be very similar to what we did before. We want to once again select random things, random per island. I need it. And if you plug this in here and test it, you see it works here. I don't really know why it didn't work the last time. So we keep this the same. We keep this not the same. I hired this with like a slight bit, and I lowered this actually to 0.25. I kept these values the same. What I did change is of course the colors I used, and I will actually plug this in so you can already check it out. The colors I used were this one for the top. If you want to read it, pause it, or you could also approximately get the same value. And for the bottom, I used this value here. If you want to copy it, pause it for a moment. And these are the exact things I used to texture it. So now we have actually already finalized our design. Of course, we want to get the ground a different texture. The way to do that, we don't really want to put in a texture on here, but if you delete this texture, we can choose whatever the ground gets. And I will not go into detail on how to make a proper ground. I will make something very, very simple just to show off the results. And if you want to edit using this, we can very easily do it actually. And that's also why I also edited this before. The first value we want to be able to change is of course the density, because the density is the most important things. It can make or break the feel of the entire plane. So we keep this density, and we might want to put the default value on something lower, so if we were to put it on a new object it would not immediately crash. Then the second value I decided to use, and I will copy this actually, is the subdivision. Even though I don't use it myself, I think it's an important thing to also have always. And you can see now it is an integer, so you can see it will move up by 1 or by 1 instead of point values. And you can delete this or you can keep it. It doesn't really matter because it will not be used anymore. Next thing I do is the scale of the layered patches, which is this here. And I bring this in here. I call this scale lowered patches, and I will call this actually the sub-D of the wheat. And actually I put this one into 1 by default. You should really change the amount when you change the scene, of course. If you want to organize it a little bit better, you can add a panel. You give it a name. I call this the wheat because it's the main thing to change the wheat. And I close this because we don't need this anymore. Now I will add the interaction. So I add the panel, call it interaction. I want to give the correct name. And now I will go to the part where I add interaction. The first thing I want to add is the object you use to interact, because it's of course the main thing. So now you can change here the object you want to use, to use the position of to interact. And the second thing you want is to actually be able to change the interaction distance. So if your object would be bigger or smaller distance. If you have a smaller object, you want to lower the interaction distance. If you have a bigger object, you want to increase the interaction distance. And the last thing I want to do is I want to be able to control the wind. And here we want to use the strength. And now I have to look back where I used it. I used it here. And you can do shift and right mouse to create one of these pads. And I will plug in here something. I will put the default value to 1 and I'll call it speed wind. I'll put it to 1 here too. And I believe that's where I need it to be. And also, of course, an important one is the difference in flow, which I standardly put on value 0.5, because it gives a nice feeling of togetherness while also being very different. Obviously, you want this to start with 0 and end with 1. You can change that. The speed wind, it doesn't really matter. The interaction also doesn't matter. This also doesn't really matter. And that's how I made the entire wheat field, which you can see here now properly. Show you how it would look like if there was slightly more wheat. So I will lower the amount and will like scale it up twice or thrice maybe. Apply the scale, higher the amount of wheat you per position. And if you look at this, you can see a simple wheat field. If you want to properly animate it, I suggest you use a bake node. Yes. You have to plug it in by this. You cannot plug it automatically. And if you have a value you really like, if you are at the point you really think this is what I want to enter it, you can go to animation. It's actually going really slow right now. I'm going to lower the density. Now it's going faster, and you want to press bake so it locks in the position, which makes replaying the animation way faster. And it will also lower the chances on crashing your PC. And that is how I made the final version of the scene. Thank you for watching. I hope you learned something, and if you want a more in-depth tutorial on some parts of this, let me know, of course. Bye bye, guys.